Hello everyone, and I'm Masato from Ritsumeikan University in Japan. And today I would like to make a presentation with this title. First of all, self-driving cars have the development of sensor technology, such as HDR or LiDAR or millimeter wave. And as a result, the market size of these sensors expected to grow grow annually. And moreover, image recognition technology is more important to understand the situation around the car. And in this context, numerous cameras have been optimized for machines, and the light out of visible range is more important, like millimeter or near infrared. And our focus is high infrared FIR. And there are some cameras using RGB-FIR, and they can capture multispectral images. And one of them uses an optical tool, this one. Oh, this one, and this is RGB-FIR spectral. And other example is use the RGB and FIR camera side by side. And ours also use the same system side by side. And previously using these multispectral cameras in case paper, multispectral pedestrian detection, and benchmark dataset and baseline. And in this paper, pedestrian detection dataset was created using RGB images and FIR images. And the dataset was analyzed for ambient light level and distance and occlusions changes. The result indicate that RGB-FIR detection had a lower miss rate in daytime and nighttime. And the previous study focused on only changes in ambient light change, but not include about ambient temperature changes. So our study had to evaluate the changes in ambient temperature, because ambient temperature strongly affect FIR images appearance of the FIR images. And then we made a new dataset including the three temperature conditions of hot and intermediate and cold. And as you can see, the pedestrian appearance of pedestrians is changing in these conditions. And here is, I will illustrate the details of how ambient light and temperature changes affect the image appearance. And let's start with RGB cameras. They capture images using reflected light by the object. So ambient light change will affect the appearance of the picture. In contrast, FIR cameras rely on the temperature of the object. Therefore, ambient temperature changes can significantly influence pinpoint and background appearance. In this slide, we will talk about our dataset. And our dataset contains of 48,000 images and 26 pedestrians. And the dataset have only one class person, and this is including cyclists and excluding motorcycles. And here is an overview of the hardware. And the RGB cameras synchronized by FIR cameras with through and logic IC. And we also aligned, because side-by-side cameras have misalignment, so we apply the homographic transformation in this dataset. And this is a video sample and synchronized two cameras to capture. And you can see clearly a small object. And in nighttime, you can see RGB is hidden many objects, but you can see FIR is clearly visualized. And hot condition is you can see very low temperature, so darker than background images and pedestrians. And now from this slide, I will start the experiment. Our presentation will feature two experiments, 1 and 2. And the first experiment aims to compare single model and multimodal models and the consistent conditions. We will show that the RGB-FIR models achieve higher accuracy when trained and tested with same temperature. The second experiment will investigate whether there are differences between training and testing temperature conditions. And we will confirm the model trained by all conditions is more robust than the model trained in specific temperature conditions. And we use EuroV8 as a base model and as the previous studies. And this slide shows the overview of experiment 1. And this experiment aims to analyze the difference between unimodal and multimodal detection. We will use the data from 3 subsets over 25 degrees and around 20 degrees and under 15 degrees. And these subsets, each of these subsets has 40,000 people. And to evaluate the model's performance, we trained RGB and FIR and RGB-FIR model with each subset data. And we will show the advantage of RGB pedestrian detection in each condition. And here are the results. And the table provides accuracy values and compared to RGB and FIR and RGB-FIR. And so compared to RGB and FIR, and RGB-FIR achieved all highest accuracy in all conditions. So RGB model improved the accuracy from RGB model and FIR model. And in this example, and you can see RGB-FIR model can detect more pedestrians than the FIR model can detect it. And therefore, this experiment demonstrates that RGB-FIR can perform stable detection in scenarios with not only ambient light changes, but also ambient temperature. And the next is experiment 2, and we will investigate the influence of the temperature environment differences between training and testing with multimodal detection. In addition to the subset used in experiment 1, we include the all subset and that covers all conditions, and this subset also contains 4,550 pedestrians. And in this experiment, we tested the robustness of the model when exposed to different temperature conditions. So especially, we evaluated the difference between environmental specific models and all models. And we first look at the model trained at intermediate temperature. And these curves are real curves, and percent indicate the average accuracy. And the model trained at intermediate temperature achieved the highest accuracy, 83%. And however, when testing at another temperature, the accuracy dropped drastically. In contrast, the model, this is this sample, and intermediate model all pass on intermodal data, but intermodal cannot give code of data. And in contrast, the model trained on all data shows almost no difference in accuracy at inter temperatures and significantly outperformance and core data. And In detection samples, the model detects more people than the model. And the table displays the accuracy of the cross test, and the model trained by specific temperature are less accurate in the other conditions. It is similar to the result that trained by both hot and cold temperatures. And this is similar to internet, as previously I mentioned. And the test image for both hot and cold images condition, and hot model cannot be for cold. Hot model cannot be cold data, and also model cannot be on hot data. Conversely, the all model, the bottom of the table, still shows maintains the top accuracy on all tests and improves the test accuracy average. Therefore, the results suggest that we should incorporate all variations, including temperature changes, into the dataset. And finally, the video on the right side is a preview of the detection sample. And EuroV8 we achieved the implementation. EuroV8 channel reached about 1600 FPS on the Jetson Edge devices. And overall, experiments indicate that the RGB-FIR detector is affected by ambient condition changes, and we can improve the robustness of the model when we include all variations of environmental changes. And therefore, we should be concerned about ambient temperature changes. This is the future works and making one model which can achieve more stable accuracy or targets to detect such as a vehicle or motorcycles or someone. Yeah, that's all. Thank you.